I am Dr. Mahammad Rafi, Associate Professor, Department of Cyber Security at Institute of Aeronautical Engineering. Today, I want to discuss about the computer network subject, in which the topic is network layer design issues. Here, network layer design issues. The designer generally, while designing the network layer, they will consider the number of other issues will be considered. Here is, based on this issue consideration, based on this the rectification of these other issues, now effectively designing the layers. Networking layers can be effectively designed. Why? Because generally these network layer can be used in a OSI reference model. Actually, the job of this network layer is now, which is delivering the data packets. Here is, the data can be delivered in the form of the packets to the, it's above layer. That means now receiving the data in the form of the data packets from the above layer and sending the data packets to the below layer. Here is now, it is responsible for delivering the packets from source stations to the destination station across the multiple networks. In between the source and destination, number of other networks can be utilizing across the multiple networks, now sending the data packets from source station to the destination station. Here is, the designers now, while sending the data packets from the source station to the destination stations, now they will consider the issues now by considering the issues and rectifying the issues. So here the effective the communication can be established, and also by rectifying these issues, here the communication should be effective and the performance of the network will be improved, and scalability also will be considered. These resolving of the issues in a network layer. Here, if you see, this is a source station and this one is a destination station. It will be between this number of the OSI reference model. Therefore, here number of layers can be utilized here, and the network layer. We are discussing about the network layer. Above layer is a transport layer at the sender side, and the below layer is a data link layer. Here is, from this other network layer, now what we are doing now, the data packets can be sent. Data packets can be sent here from source mission to the destination mission. Now the data packets can be sent. Here, these are the packets, which is network layer now, which is responsible for sending the data packets to the data link layer in the form of the frames. Whatever the packets now which is sending here, which to the below layer in the form of the frames need to send. And from that the data link layer here, whenever this the data reaches to the physical layer, now it will be converted. The data here, the sending information or sending data can be converted in the form of the binary form. That is a 000111000. In binary form, now it will be converted into the binary form. That is a physical layer. Via this the physical layer, now it will be converted into the binary form. Here the source packets now here delivered from source station to the destination station, now effectively deliver the packet within in time. This is the job of the network layer. So while transferring these other packets, now generally the number of the issues can be arise between the source and destination. While we are going to delivering the packets from source station to the destination station, here the number of issues will be arise. What are the issues? Means now designing issues for the network layer. While considering the network layer, if you are going to communication, if you are going to establishing the communication, here the number of other issues can be faced. That is First issue is a routing issue. Routing issue means now number of other routers between the source station and the destination of the station, arranging in between these now number of other workstations, number of in this the number of workstation, number of other routers can be arranged. Among the number of other routers, the optimal path, finding optimal path, that is a routing. Routing is nothing but a determining or finding the optimal path from the source station to the destination station for data packets delivery. Data packets delivery to travel across the network from the source station to the destination station. Here is the challenges while transmitting this data, that is now which is handling the large scale routing in a complex network. Large scale routing in a complex network. Dealing with the dynamic routing, especially changing the network other topologies. Dynamic routing, changing in the network topologies. Here these are all the challenges in a routing. So by resolving these other challenges, by overcoming these other challenges now, optimal path can be found from the source to destination. In between this, number of routers will be arranged. So the finding the optimal path is a issue. It will be fine if you find the optimal path now within these fraction of seconds now. The data effectively can be transferred from the source station to the destination station. Next one is a addressing. So addressing means now the objective of this addressing. So whom to sending the data, it is a one issue. Or these are the communication, or these are the transmission media. Generally sending data, whom to sending the data. So it is a one general issue. So in this other issue now, the objective is assigning a unique identifier. Here is now unique, the identifier can be assigned to every device, on the network. That means IP address for this instances. Unique address can be assigned to ensuring the proper the packet delivery. Here assigning unique address, it is a one issue in a large size of the networks. If you identify the unique address of the device now, that identified unique address of the device, generally we are transmitting the data, we are sending the data to that other particular other device. The challenges for finding the address means now efficient allocation of the addresses, especially the networking area is a very large networking area. Now address allocation is a one challenge. If the networking area is a very large area, so this is the one issue. That means IPv4 and transition to the IPv6. So in this large area now, the translations, address translations also, it is a one big issue. Here the hierarchical addressing. So in this other case now, the challenge is hierarchical addressing. Hierarchical addressing means now large area network now which will be arranged the addresses in the form of the trees. In a hierarchical structure form now, addresses can be found based on the tree structure address now, effectively finding the unique address. A unique address now easily we can find. That is hierarchical addressing. So this is which ensuring the scalability. That means now this hierarchical addressing now which is identify the number of other devices. How many devices are connected to over the network? How many routers are connected to the network? That means the scalability now which ensures the scalability. The numbering, it is giving the numbering and preventing the routing tables now, which is preventing the routing tables from growing the excessively. Routing tables, if is there any routing tables, no, it will be preventing, and address resolutions protocols can be used. Here the address resolution protocols. This address resolution protocol usage also it is on challenge here. This address by using this address resolution protocol now you have to mapping the logical address to the physical address. Here the logical address generally now it will be generated while executing the programs. By the CPU while executing the programs this logical address will be generated and it will be converted to the physical address. Once it is converted to the physical address now, the transmission, the action can be take place. That means data transmissions can be done. Once if it is converted to the physical addressing. So here, if you take this now, this is the addressing now. Here the unique address. Now every device now, device 1 has its one unique address, device 2 has one unique address, the IP address instances. It is also one IP address, it is also one IP address, unique address. Now, here in between this network, this is on network, so it is arranged in a one network and it is also arranged in a another other network, number of other networks now, in between this number of networks, the communication. So that is a with one network to the another network now if you want to establish the communication generally these two networks can be connected using the routers. By connecting the routers now the communication can be established from the one network to the another other networks. By this unique address identification exact wherever you want to send the data in a particular the related the network now we can transmit the data, we can transfer the data to the exact other device. Packet the forwarding, the next issue is packet forwarding. So in a network here the packet forwarding, that means now packets the forwarding from one network to the another network through routers. So this is a one other task. That means now network from one router to the another router towards the final destination, towards the final other destination now. So this is the one issue here, moving the packets through the network from one router to the another router. Challenges means now speed up the forwarding and minimizing the delays. Now packet delivery speed increasing and delay minimization, packet delivery delay minimization, it is one of the challenge issue. Ensuring the packets now which is reach their other destination even in the case of the network failure. Here suppose if in case of any network failure, if any packets are losses, any packets without losing packets, without damaging the packets now, we have to ensure that now packets can be delivered to the other destination effectively. So ensuring packet delivery to other destination is a challenge for packet forwarding in case of network failure. Here it is a one challenge, and handling the packet as the fragmentations. That means generally the packet fragmentation, the meaning of the packet fragmentation means now here it is the space will be the wasted. Suppose the packet size is which is 20 MB of the size of the packet. Now the data size is 10 MB data. Here remaining 10 MB space in a packet will be the waste. That is the fragmentations. Handling fragmentation in a packet as a forwarding, it is also one of the challenging issue. And reassembling, particularly for the large other packets. Which the suppose data, large number of other data, bulk amount of data. Now we are going to other transferring. So in these other particular other cases, data integration, data reassembling is a most the important issue. It is the most important the challenging in a data in a packet forwarding. Here if you see the packet forwarding now, generally sender mission to the receiver mission. That is the destination which is having one unique address, IP address. That is the PC2, and here is also the PC3. So that is a PC1, PC2, another PC. Now PC1 to PC2. PC1 will be considered as a sender mission, and PC2 will be considered as a destination mission. So the packets can be forwarded by using the switches, via the switches and routers. These messages, the packets can be transferred. Forwarding the packets. Now, how the packets are forwarding means store and forwarding, which is utilizing the concept of stored and forwarding. So these are the packets. Now routers, via these routers, the packets can be transferred, forwarded via the router. So in this other router, what it will do means now, router which is having it's a router memory. In this the router, the memory, these packets will be stored, and after some time now it will be delivered to the next router, and from next router to the destination. Now these are the packets, now storing the packets and forwarding the packets. Storing, forwarding is a issue, that is a packet forwarding, you can say it as a. Here while forwarding these other packets, now the packet now which is having the destination IP address where we are going to transfer it. Here is the destination IP address is 192.168.3.10. It is a destination address. Here each and every packet having the destination address and the source address. Source address 192.168.3. Something, the source address and destination address. With the help of the source and other destination addresses, now the packets can be forwarded, and other IP fields also, and the data field also, which is having the data field. Suppose the data size is less than this the packet size. Now here generally the packets, while forwarding these other packets, we can follow the store and forwarding technique. By using this the store and forwarding the technique, packets will be transferred from source station to the destination station. Here this is the one challenging issue. Here is the source IP address, destination IP address, other IP fields and data fields. While reaching this other destination, now which is receives the exact and accurate other data. Error handling and diagnostic. Generally errors in a packet transmission over the network media and network layer. Here generally two types of these errors can be handled. One is a single bit error and burst error. Single bit error means now while transmitting the data, receiver receives only one bit different. So that is a single bit error. Suppose burst error means now the receiver receives the multiple bits are different, whatever the sender is sending. So then sender bits, for that sender bits, receiver bits are the different. Error means now whatever the sender sending, the receiver receives the different bits. This is the errors. That can be two types of these errors can be handled. Single bit error, only one bit will be different. Burst error, more than two bits will be the different. The objective is now, which is the reliable packet delivery. Here the objective of this error handling and the diagnostic means reliable the packet delivery is an objective, and correct transmission of data. Another one is the correct transmission of the data is another objective. And challenges means here detecting and handling the transmission errors. Detecting and handling the transmission errors or corrupted packets. Whatever the packets are corrupted via the checksum, now. So this is the other challenging. And implementing ICMP protocol. Implementing ICMP protocol means now Internet Control Message Protocol. Here Internet Control Message the protocol. So for the error messages, that is, for example, it is a unreachable destination, and dealing with the packet loss, retransmission in case of the errors, retransmission in case of error. So these are all the challenges. And congestion control. Congestion control means now here managing the network or the traffic to prevent the overload or other congestions. Challenges means here now whenever the traffic is overloaded, generally these are the congestions will be arise. That is a overloading issue. Overloading issue. The challenges are detecting when a network or router is congested. So it is the conjunction detection is one of the challenge, and also avoiding the packet loss due to this the congestion, overloading of the data, and maintaining the throughput. Here maintaining the throughput. Throughput means now the per second how many data packets are conjected, how many data packets are overlapped. So this is avoiding of this other conjunction is one of the challenging issue. Implementing flow control mechanism. So flow controlling, if it is overloaded, the data is overloaded through the network. Now flow control mechanism, implementation of the flow control mechanism, it is so one of the main issue such as a buffering, pacing, and traffic shaping. So these are all the challenges. Managing traffic, managing the traffic during the peak hours. During the peak hours means now maximum data the transmission time. Here is the congestion. This is a network of the congestion. This is a network 1. Network 1 having the number of routers. Router 1, router 2, router 3, router 4, 5, 6. 6 routers now. Network 2 also which is having the 6 routers. So data can be sent from source to destination between these via this other network through the number of other routers. Here generally the routers are the data packets, whatever the data packets now we are going to transferring. Whatever the data packets now we are going to transferring, whenever the overhead is arise, that means the resources, more resources are utilizing. The packets are coming from the network 1 and some packets are coming from the network 2. Both the packets are coming from network 1 and network 2. If it is overloaded, the data is overloaded, it will be conjected and overlapped. So in this other case now, so resolving, avoiding this other overlapping, so it is a big challenge. Why? Because now the data losses, packet losses will be arised. That means here R5 finds that R6, R12 path is free, isn't it? So this is path is free. So whenever it is the free here, whenever it is coming on a same path in opposite direction, here the congestion will be arised. Here also now it is finding that free. Here the congestion, here also the congestion will be arised. More than one packets are coming. So avoiding these the congestion, that means finding the without traffic. So this is a big the challenge in a network the packet delivery and in a communication. Here is the scalability. Scalability means now if you devices, more number of other devices. Whenever the network size is increasing, device utilization, it is a challenging. And users depends upon the more number of other devices and the users the connectivity, more number of user connectivity also, it is also a challenging issue. Supporting the growing network size. This is the objective, and devices, growing devices or growing the users. Many challenges are managing large or dynamical routing tables, which is ensuring that network layer can handle, which is increasing the traffic without degrading in a performance. Without degrading the performance, accuracy, the scalability, and which ensures the network layer, which handles the increasing traffic. Now, which is handling the increasing traffic without degradation in a performance. Supporting new devices and the protocols without breaking the compatibility. Here, security. Providing security for your packets, whatever the packets are the transmitting over the networks and over the routers. Now providing security, it is one of the big issue. Ensuring secure communication at a network layer. Using network layer, whatever the packets are delivering from source to destination, providing security from the unauthorized users or unauthorized access. That means any modifications or any attackers. Now it is protection, providing protection for data. So it is a big issue. There is a challenges for this issue is implementing encryption technology. So it is one challenge. And authentications, giving the authentications at the network layer, and protecting against denial of services attacks. That is a cyber attacks. Denial of service attacks means cyber attacks over the internet. And network intrusions. From the network intrusions and denial of service attacks, protection. It is a one challenging issue here. Providing the secure routing and path management is another issue. Quality of service. Quality of the service means now providing quality of service to the whatever the data we are going to other transferring. The objective for this the quality of service is which ensures that network can provide the guarantees on a bandwidth. Suppose if the bandwidth is less the bandwidth now, data traffics will be the arises now, the congestions will be the arises. So that's why we can't provide the quality of the service now. That's why providing the guarantees of the bandwidth. That means if it is a bandwidth, is more bandwidth, the more data can be transmitted. And the latency and jitters. Latency and jitters. Latency means delay in time. For whatever the packets now we are going to transferring from source to other destination, if the packets are delayed in time now, which is the latency, that will giving the without latency. So it is one of the objective. And jitters, that is a jitter for different types of traffic means the meaning of the jitter means time variation. Packet to packet delivery is a time variation. One packet is delivered in 1 second, another packet is delivered in 2 seconds, another packet is delivered the 4 seconds. Now these are the time variance. It will be the providing the guaranteed time variance. So this is the objectives of the quality of services. If you resolve all these one here, we can provide the quality of the services from over the network, and the effective communication can be provided, and the performance and the accuracy also can improve these whatever the communications now we are going to establishing, whatever the data we are going to sending here, providing the accurate data can be transferable. Challenges of this one here, differentiating the traffic types. The traffic types are now differentiating voice data and video data or normal text differentiation. That is a categorization. It is one of the challenge, and prioritizing the critical traffic. Critical traffic is one of the challenging issue. Implementing traffic management policies. Traffic management policies to maintaining the quality of service during the congestions or network failure. Congestions or any congestions or any network failure now. So this is this one is challenging. Supporting the real-time communication. Supporting real-time communication for services like voice over IP or video streaming. So this is the challenges. And interoperability. Interoperability, that objective is now which is ensuring that devices, that means internal operations, different vendors and different network other technologies can work together. So this is the objective of the interoperability. The challenges for is now adhering to the standard the protocols like internet protocol, IPv6 protocol, to guarantee the cross platform capability. Guaranteed the cross platform capability means now this cross platform capability which is using the different operating systems, different applications, running the different the softwares or different applications on a different operating system. So like this now, adhering the standards. So this is the one challenging issue. And handling the communication between the different types of the network. Here different types of the networks now, if you want to handle the communication between the different types of the network, that is a local area network, wide area network and satellites. Supporting tunneling and encapsulating techniques. for secure and transparent data. Secure and transparent data transfers now. So here these are all the challenges. These are all the other challenges. Multicast support. Multicast support means now the objective of the multicast supporting means now here, which is allowing the efficient delivery of packet. Efficient delivery of packets to multiple destinations. That is a group of the communication. Challenges for this one is supporting the multicast routing protocols. Supporting multicast routing protocols, that is a protocol independent multicasting. So this is one of the challenging. That means multicast routing protocols now, which is transferring the packets to the at a time multiple devices. Transferring packets to at a time to multiple devices, it is one of the challenging issue here, and which is ensuring that now multicast traffic is delivered efficiently without the excessive the duplications or network loads. Here this is a multicast routing. In this multicast source, so this one is a multicast source. Here from this multicast source now finding the optimal path. So this is the optimal path now. Data packets can be forwarded to the multiple devices at a time. Now this is a receiver 1, receiver 2, receiver 3, receiver 4, receiver 5 at a time. Here all multiple devices at a time. Now we are transferring the data packets. Whatever the data packets are, you are transferring via the routers now. These routers now, which is storing the data in a routing memory and forwarding one router to the another router. Here this router forwarding to the another router depends upon the shortest path. So whatever the shortest routers are, shortest paths are there, based on this shortest path now, data packets can be either delivered to the one router to the another router. Here the finally multiple sources. Multiple sources can be transferred to the multiple destination. That means multiple devices can be transferred. That is a multicasting. Implementation of the multicasting, multiple device to multiple communication is a challenging issue. So these are all the network issues. Network issues can be utilized over the network layer. The designers now, while designing the network layer, he need to consider all the issues. By considering all the issues, if you design the network layer, now efficiently, effectively transferring the data from one device to the other device. Here is, while designing this network other layer, the performance, towards increasing the performance, if issuing all these issues are identified, resolve the other issues, the performance and accuracy and scalability also increased. Here the textbooks for this network layer design issues are data communication and networking and computer networks. These two are the textbook. Data communication and networking by the Foregen and computer networks is the Tenenbaum. These are all the textbooks. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.